first problem we're going to talk about today is on integration and average values. This is going to be integration over some domain defined like this, and we're going to find the average value of it. So the first thing I always do for these problems is draw my domain. So this is the xy plane. I have y is equal to 4, which I'm going to draw. So I'll just draw this here in green. Y is equal to 4. And the reason I do y is equal to 4 is I know that y is between 0 and 4. So I'm also going to draw y is equal to 0. And then my next one, I'm going to draw x is equal to 1. Because here I have this as my boundary, x is equal to 1. And this last one is x is equal to y over 4. So y is equal to 4x. So y is equal to 4x starts at the origin here. It has slope 4. And I drew it intersecting this because when x is equal to 1, y is equal to 4. So they intersect. Okay. So now I want to be between y equals 0 and y equals 4, but I still could be here or here. The way I figure that out is that x has to be less than 1, but it has to be greater than this line. So this is the region I'm integrating over. Okay, so if you remember our definition for average, well, this is 1 over area of D, and then double integral over D f of x, y, dA. Okay, so first I'm going to find the area of D. How are we going to find the area of D? Well, area of D is just a triangle, right? So it's 1/2 height times width, right? So the height is 4. The width is 1, so this is equal to 2. Okay, now I want to set up the integral. So we can set it up in terms of x or y. Let's try to just set it up first in terms of x because this is how it's given to us. Let's first try to set it up like it's given to us here. So we're going to go from 0 to 4 on the outside, and we're going to go from y over 4 to 1 on the inside. And my f of xy is y ln x cubed plus 1. So this would be dx dy. But we notice there's a problem here, right? How am I going to integrate this? If I try u sub, and I get du is equal to 3 x squared dx. So this isn't going to work. That doesn't show up here. So to go to the next page, we're going to need to reverse the order of integration. Okay, so what we know is our domain looks like this. We have y over 4 is less than or equal to x, less than or equal to 1. But we're going to want to write it the other way. So if we go back and look at this, let's write x in terms of numbers. We can say x starts at 0 and goes to 1. So let's do that. We're going to have, I'll write this in purple as my new one, and I'm going to say, well, my new one is x is between 0 and 1. Now if x is between 0 and 1, y is going to be between 0 and this one. Well, what is this equation? I just wrote this. Y is equal to 4x is the equation for this line. That means we're going to have 0 less than or equal to y less than or equal to 4x. Now this still describes the same region, so the area of the region stays the same. And our integral is going to look like f av is 1 over 2, and now we're going to have the numbers on the outside 0 to 1, 0 to 4x here, and I have y, this doesn't change, y ln of x cubed plus 1, so now I'm doing dy dx. So if you see, we're doing dy dx here, and here we had dx dy, so we're doing different ones, different integrals. Same number. Okay, so this is going to be 1/2, 0 to 1. I'm going to bring my ln x cubed outside, because it doesn't depend on y, right? So I have ln x cubed plus 1, and then 0 to 4x, y dy. After I do this integral, I'll do dx. So just do our first integral, 1/2, 0 to 1, ln x cubed plus 1. Now this is going to be 1/2 y squared from 0 to 4x. And then we'll integrate that to x dx. So 1/2, this doesn't change, it's 0 to 1, ln x cubed plus 1. And we have 1/2 times 16x squared, and the lower bound just gives 0, right? Okay. So, these cancel, this becomes an 8. This 8 cancels, it becomes a 4. We look at this thing. So what I really have is 4, whoops, I went black. 4, integral to 0 from 0 to 1, x squared, ln x cubed plus 1 dx. And this is good, because now I can do the u sub. U is equal to x cubed plus 1. Right, I always want to u sub out this if I have ln of something. Du is equal to 3 x squared dx. So, this becomes 4 over 3. So let's be more careful. This becomes 4. Our bounds change. If x is equal to 0, then u is equal to 1. So our bounds become 1. If x is equal to 1, then u is equal to 2. 1 to 2. ln x cubed plus 1 is just u, ln u. And then I have x squared dx, which is 1/3 du. So my integral, I'll write in the next page. We have f av is equal to 4 over 3, integral 1 to 2, ln u du. Now, you can integrate this by parts. I'm just going to write down, I have the formula written down. So integral ln u is actually given by u, ln u minus u, or we're going to do this from 1 to 2. Now, if you didn't know this, you could figure this out on the test by doing u, and I recommend trying this if you haven't seen this. U is equal to ln U. Sorry, that's bad. We want to do integration by parts. So I'm going to say P is equal to ln U. dP is equal to du. dV is equal to, oops, that's not going to do this. dP is equal to 1 over U du. And then dV is equal to du, so that V is equal to U. And then do UV minus integral V du, integration by parts. Try that if you haven't seen it. I'm going to assume you have seen it. That's a pretty common one. Okay, so we have 4 over 3 on the outside, 2 ln 2 minus 2 minus 1 ln 1. Well, we know that. That's just 0. Minus 1. And we get 4/3 2 ln 2 minus 2 plus 1 minus 1. That's our average, that's our area. Or sorry, our F hat.